So we have a 5 kilogram block that's pushed up against the ceiling, and we want to determine the force of friction that the ceiling exerts onto the block. So I started out with my free body diagram with the force of the push up and to the right, force of gravity down, and then the normal force also down perpendicular to the surface. And then our force of friction is to the left. So I started out by defining my origin as being right here, so up in the y direction is positive and to the right in the x direction is positive. So if we know that the angle to the vertical is 20 degrees, and we can find out that the angle to the horizontal is 70 degrees. Then we can draw a nice triangle and easily determine the x and y component of the force of the push. So the x component is going to be 150 times cosine of 70, and the y component is going to be 150 times sine of 70. So we know that the block is stationary, so that means the sum of the forces is going to equal 0. So it's not moving left or right or up or down. Since we want to find the force of friction, we can set the sum of the forces in the x direction equal to 0. So that means that all the forces to the right are equal to all the forces to the left. So that means the force of friction is equal to the x component of the force of the push. So the force of friction will equal 150 cosine of 70, and then we know that is going to be 51.30 newtons, and then it's going to be to the left. So part 2 says, what if we change the coefficient of static friction to be 0.45 and the coefficient of kinetic friction to be 0.35? And it wants to know what's going to happen to the block. Well, we know that the block is going to move in the x direction if the maximum force of static friction is less than the force of the push in the x direction. So that means that we want the force of our push to be greater than the maximum force of static friction. And then we know that the force of static friction has its maximum at n times m sub s. So first we have to find what n is. So if we go back up to our free body diagram, you can see that our n corresponds to the y component of our free body diagram. And then we know that it's not moving, so we can set the sum of the forces in the y direction equal to 0. And then that would be the y component of our force of our push, the normal force down, and then mg. So then we can say that our normal force is equal to 150 sine of 70, which we found as the y component, minus mg, so 5 kilograms times 9.8 meters per second squared. So we can solve for the normal force, and we plug it in, we get that it's 91.95. So now we're gonna see what the static friction is. So we have n and we have our new m sub s. So the maximum static friction is going to be 91.95 times 0.45, and that is 41.37. And then we know that our X component of our force of the push is 51.30 newtons, and since that's greater than the force of static friction, that means it's been overcome and the object is now in motion. So it's accelerating to the right. And now we want to find out how much is it accelerating by. Well, we know that acceleration in the x direction is equal to the sum of the forces in the x direction divided by the mass. So we know that the sum of the forces in the x direction, that would be the force of friction, of kinetic friction, and then the x component of the force of the push. So we already found what the normal force was, and we were given a new mu sub k, so we just plug those in. And we get that the sum of the forces in the x direction is 19.12 newtons. So to find out how much it's accelerating by, we just take that and divide it by the mass. And then we get 3.82 meters per second squared for the acceleration. And then we can double